Hi, and welcome to 4.06 Stoichiometry. These are the Common Core standards that we're applying to this lesson. The lesson objective: we must remember some previous information. In 4.09, we learned how to use molar mass to convert grams of one chemical to moles, and vice versa, to convert moles to grams. You must have mastered that concept before doing this lesson. Molar mass is used in almost every problem in 406, 407, in 408, Module 4 exam, semester exam, and most of Module 5. So please make sure that you have mastered molar mass. If you have not, please go back and watch the recording video for that. Please do not continue if you have no idea how to balance equations or if you have no idea what molar mass is. Stoichiometry means the math of chemical reactions. We are going to be able to use relationships in our balanced equations in order to convert one chemical to another. For example, if we had a particular reaction and we knew how many reactants we had and we needed to figure out how much of our product we were going to make. Or if we knew we had to make a specific amount of our product, how much of our reactants would we need to go get? That is stoichiometry. And in real world chemistry, we do use stoichiometry often. And it's in more fields than just chemists running around in white coats. Food chemists, like the chemists who make all the different flavors for Doritos chips, those are food chemists. Those are people sitting there doing stoichiometry and figuring out the ratio of their reactants. In doing stoichiometry, we need to use molar mass, which of course is our previous material, and molar ratio. 4.06 introduces this new concept of molar ratio, and we're going to see that as we apply it in a problem. A review on molar mass: keep in mind that molar mass is defined as the mass in grams of 1 mole of your substance according to the periodic table. Yep, you're going to need your periodic table. So go get your periodic table. You're going to need a calculator and some scratch paper and a pencil so that way you can do these problems at home while I'm working through them. Stoichiometry is one of those concepts where you must learn by doing. For example, if I wanted to learn how to play the piano, I can't just sit here and watch videotape of a really good concert pianist playing. I'm not going to learn how to play just by watching him. I have to learn by doing it. Stoichiometry is just like that. You cannot sit here and just watch me do problems and then expect to be able to understand it and do it yourself. You must try them on your sheet of paper, get as far as you can in these problems, and do as well as you can. Let's say we had the reaction hydrogen gas reacting with oxygen to form water. In 4.02, we learned that we must balance the reaction because of conservation of mass. Whatever mass we start with, we have to finish with that same mass. And in chemistry, oftentimes our chemicals do form in specific ratios. So we end up having to balance the reaction. Now, with stoichiometry, we can actually read the equation a little bit different. We read this as 2 moles of hydrogen, 1 mole of oxygen, and together they will form 2 moles of water. If you look at the graphical representation, we see 2 moles of hydrogen reacting with 1 mole of oxygen to form 2 moles of water. Now remember what a mole is. A mole represents a specific quantity. Of course, I am not going to draw 1 entire mole of hydrogen on the board here. That's way too much. But we have the basic ratio here. We know that for every 2 moles of hydrogen, we need 1 mole of oxygen and 2 moles of water. 2 to 1 to 2. That is our molar ratio. When we're doing stoichiometry problems, sometimes we don't need molar ratio at all. Sometimes we do. Sometimes we only need 2. A question might ask us, how many moles of water can we form from 7.2 moles of hydrogen reacting. And then we would need to use a mole ratio for hydrogen and water. So remember, molar ratio, that is from the coefficients in the balanced equation. That's where we get the mole ratio from, the coefficients in the balanced equation. Look at oxygen. Oxygen doesn't have a coefficient. So really, it has a 1. Therefore, we would say 2 to 1 to 2 ratio. When we're solving stoichiometry problems and equations, they can get quite intense. So if we can follow a general flow or general steps, it will help you figure out how to do these problems. The first thing is we have to have a balanced equation. If you don't have a balanced equation, then you need to balance it. Sometimes you might have a problem from like 2.04 or 3.09 where it's just talking about one chemical. Well, if you're just talking about one chemical, there is no reaction, right? But if you have a problem where it gives you information about one chemical and asks about another, that's your balanced equation. Please make sure that you have a balanced equation. You may get to problems in 4.07 and the module exam where it gives you the equation, but it says unbalanced equation. You have to make sure to balance that equation first before doing the math. Okay, next, we're going to make a list of what we know and what we are solving for. Basically, we are going to take the word problem out of word problem format. We're going to make a list. Sometimes I like to draw arrows to the reaction so that way I can tell which chemical I have information about. Then we're going to actually start doing the math. And when we do that, we are going to start by writing down what we were given. Start with what you're given. Many, many times students ask, I don't get this. I don't understand where to start. Okay, keep it simple. Start with what you're given. Then we're going to use whatever conversion factors we need, such as molar mass or molar ratio, to convert with what we started to where we're going. Sometimes this means that our stoichiometry problems may require more than one step. This is our general flow chart. This is actually from your lesson, so if you don't recognize it, please make sure that you are clicking on everything in the lessons because you are held accountable for knowing everything in these lessons, so please make sure. This is the general flow chart. This is if you were starting with grams of one chemical, A, and then you had to convert to moles. We know we're going to divide by the molar mass. And then once you have moles of that same chemical, we can use the mole ratio to convert to moles of B, which means another chemical. So right here is the new step, here in red, that you're learning in 4.06. If you are given information about one chemical and asked about another, that's when you're going to use mole ratio. The moles of B divided by moles of A, of course those are your chemicals, your starting product, your starting chemical, your ending chemical. And remember, these numbers in here are from the balanced equation. We have to insert the coefficients from the balanced equation. Once you get moles of your new chemical, if you need grams, you can convert to grams using the molar mass. In each problem, if you're given two different chemicals, what you want to do is find out, okay, what are you given? Circle where you're starting. Where are you starting? What did it give you? Did it give you moles or did it give you mass of that first chemical? And then, where do you need to go? Where is your final destination? Does it ask you for moles of your second chemical, or is it asking you for grams of your second chemical? If you do this, okay, if you circle what you start with and what your final destination is, you can map out your route. You can figure out what you need to do to get to the final answer. Let's solve this problem. How many moles of oxygen are in 43.6 grams of oxygen? So we know we're asked for number of moles of oxygen. Recall that oxygen is diatomic from lesson 3.06. We have our 7 diatomic elements. It told us that we have 43.6 grams of oxygen. To solve this problem, we're going to start with what we're given. I was given 43.6 grams of oxygen. We put our X, we put our line. Whatever unit you start with, you put that unit on the bottom. Whatever unit you see at the beginning, that's a unit you put on the bottom. Now comes the hard part. Now that we have grams, what can we do? Well, it gave us grams, it's asking for moles, and we have to recognize that molar mass is the mass in grams of 1 mole of your substance. And now we need to go to the periodic table. We look up mass of oxygen. I see that mass of oxygen is 15.999. Close enough to 16. We can round that. However, my formula says O2. Therefore, my mass of O2 is roughly 32 grams. And now what we do is we see that grams of oxygen cancel. I have moles of oxygen, which is what the problem asked for. Therefore, I'm done. I put my equal sign. I multiply everything on the top. I divide by everything on the bottom. My calculator gives me 1.3625. However, my measurement gives me 3 significant figures. Therefore, I'm going to round my answer to 3 significant figures. I'm going to include my unit, which includes my chemical, in my final answer. Remember, a number without a unit is meaningless. Go ahead and pause this recording and complete the second review problem. How many grams of calcium, all right, question mark grams of calcium, are in 1.25 moles of calcium? Notice how I'm making a list? Then it gets it out of word problem format, and it's a little bit easier for me to understand. To start any math problem, you're going to start with what you're given. I was given 1.25 moles of calcium. Now I have to convert to grams. So what I'm going to do is put my X, I'm going to put my line, and this line represents our conversion factor. Remember back to Module 1 when we learned about dimensional analysis and how to convert one unit to another. We draw a line and we have our conversion factor. Moles of calcium is what I started with. So remember, keep it simple. Moles of calcium is what I started with. Moles of calcium is what's going to go on the bottom here. Follow your unit. Keep it simple. Do not overthink this. Whatever you see at the beginning, that's what goes on the bottom, because in algebra, the unit up top gets canceled by the unit on the bottom. Moles of calcium, I can convert moles to grams of the same chemical using the molar mass. Remember that molar mass is always of 1 mole. My molar mass of calcium is 40.078. My moles of calcium unit cancels. I have grams of calcium, which is what the problem asked for, therefore I'm going to put an equal sign. I multiply everything on the top and I divide by everything on the bottom. My calculator gives me the answer of 50.0975. However, my measurement has 3 significant figures, therefore my answer can only have 3 significant figures. Uh-oh, but I see a 9 is next. Therefore, I have to round, so it's going to be 50.1 grams of calcium is what I'm going to report as my final answer. How many moles of oxygen gas can be formed from the decomposition of 34.45 grams of water? Notice how they're giving us information about one chemical, water, and asking us about a different chemical. That's when you need a balanced equation. That is the new stuff for 4.06. They give you information about one chemical and ask about a different chemical. That is our A and B. Okay, A is our starting chemical, B is our final destination. We need a balanced equation. I have already given a balanced equation to you for purposes of time for the recording. Go ahead and pause this recording. Get as far as you can. Make your list of what you know. Circle your starting destination on this chart. Circle your final destination. And you can go get this chart from the lesson and print it if you want. Keep it with you for the rest of the module. You're going to need this in the next lesson too. And then start with what you're given and get as far in the math as you can. And when you're ready to resume, hit play. Alright, so let's go ahead and work through this problem. I was given 34.45 grams of water. What I like to do, instead of making a list, in these type of problems where they give me information about one and ask for another, I like to actually write my numbers by my chemical in the reaction. This kind of helps me figure out what I'm doing. Okay, and then oxygen, I don't know my oxygen because that is what it's asking me for. So right away I can see that I'm starting with water and I'm finishing with oxygen. So my starting place is grams or mass of water. Excuse me. So I'm starting with mass of water. And then my final destination, my B, is moles of B. So it's asking me to solve for moles of B. Notice how I don't have to go all the way. So what this tells me is that I have to start with mass of A. I'm going to divide by the molar mass of A, and then I will have moles of A. Once I have that, I'm going to make the big leap by multiplying by my molar ratio, and then I will have moles of B. This tells me that this is a two-step process, which means I'm going to have two conversion factors. Start your math by writing down what you are given. 34.45 grams of water. And right away, I know many of you are going to get kind of lazy and you're not going to want to write down your units. You're going to try to get shortcuts. I've had very, very, very intelligent students make very bad mistakes in stoichiometry because they were at the top of their class. They had, 99 to 100% in every class since kindergarten. And they would get kind of lazy and they would just write down the numbers. And I guarantee you, most of the time, their mole ratio would be upside down because they weren't keeping track of their units and their chemicals. They would make mistakes and get the wrong answer, and that can be very, very frustrating. So whether you're at the top of your class or not, please do not be lazy with 406 and 407. Please make sure that you do take the extra couple of seconds it takes to write down the unit and the chemical. Alright, so we start by what we're given. We put our X, we put our line, this is our conversion factor. Remember, whatever unit we start with, we put that unit on the bottom. And that's how you know. Put that unit on the bottom. And notice here in step number 1, it tells me to divide by molar mass. Well, guess what? My molar mass is on the bottom, isn't it? So I already knew that. Molar mass is the mass in grams of 1 mole of your substance, of your chemical. Same chemical. That's another common error. Students like to just start putting whatever chemical they want on top. You cannot. It's the same chemical. Okay, it's molar mass of A. And it's always 1. Remember the definition of molar mass that we've learned already. Molar mass is the mass in grams of 1 mole of your substance. It does not matter what the balanced equation is. Molar mass has nothing to do with balanced equation. So now we look at the periodic table. We add up the mass of 2 hydrogens, 1 oxygen, and we get a mass of 18. So our grams of water cancel. We are left with moles of water. That's not what the problem asked for. Remember, my final destination is moles of oxygen. Therefore, I'm not done. So I put an X, I put another line. Okay, so I'm here. I'm at moles of water. Now I have to make that long jump to moles of my new chemical. This is the basic formula that we're going to write down. So we're going to put moles of A. Now what was A? Remember, whatever unit you have up top here, that's the unit that you put down here. Follow your units. What's up top here goes down here. That's A. Moles of B is our final destination. What are we converting to? Well, the question asked for oxygen gas, so guess what? We're going to oxygen gas. Quick pop quiz. Where do these numbers come from? How do I know how many moles of water to how many moles of oxygen? If you said the coefficients in the balanced equation, you are correct. We need those coefficients. In front of water, there's a 2, so we put that down there. In front of oxygen, there is no coefficient. Oh no, what do I do? We put a 1. Oxygen has a 1. So moles of water cancel. I'm left with moles of oxygen on top here. That is what the problem asked for. I am at my final destination. Therefore, I put an equal sign, and now I just plug it in my calculator. We multiply everything on the top, and we divide by everything on the bottom. On my calculator, I'm going to do 34.45 times 1 times 1 divided by 18 divided by 2, and your calculator will give you an answer 0.956944. But please be more intelligent than your calculator. Your calculator does not understand significant figures. We do. Therefore, we look at our measurement. Our measurement has 4 significant figures. We have a decimal in our answer, therefore we go to the first non-zero and we count 4 over. Therefore, my answer is going to have 4 digits there. We look at the next one just to make sure we don't have to round up. And then we're going to report 9569. And is that all? If that's all you write down, you're going to lose points, because this is actually moles of O2. And notice how I'm writing it moles, M-O-L-E-S. You can write M-O-L-E, or the abbreviation is M-O-L. I know, not much of an abbreviation, is it? Any of those are fine. Second type of problem. How many grams of nitrogen gas are needed to form 2.56 moles of ammonia? Go ahead and on your scrap sheet of paper, write down your list of what you're given, what you're asked for. Circle your starting point and your final destination. Start the math and get as far as you can. Hit pause, and when you're ready to resume, hit play. All right, let's go ahead and get started. The question says, how many grams of nitrogen gas, so I'm going to put question mark grams, are needed to form 2.56 moles of ammonia? We're forming it, so I know my ammonia has to be my product. So it's 2.56 moles. Since I'm starting with ammonia, that's the one it gave me the number about, I know that A is going to be ammonia and B is going to be my nitrogen. I'm starting at moles of A. Therefore, this is where I'm starting. Notice how it's a different start point than the last problem. And that's one thing that makes stoichiometry a little bit hard, is that not every problem is the same. You really have to understand where you're starting and where you're finishing. You can't just go at these problems blind. You know, you can't just get in your car and just start randomly driving and hope that you end up where you're supposed to be. Okay? You really got to know where you're going. And so, if you can get used to using this flow chart, I think it'll really help. Now, of course, every student is different, so what works for one student doesn't always work for another. However, I think this really helps keep it organized, and it really helps answer some of those questions that students ask. Where am I starting? Where am I going? What do I multiply by? This actually tells you. Alright, so we're starting with moles of A, and we're finishing with grams of B. So this is our final destination. And so we are making one hop here, so that's one conversion factor. And then from moles of B, we have to convert to mass of B. So this is another two-step problem. However, it's at 2 different steps, isn't it? So to start with, we're going to start with what we were given, 2.56 moles of NH3. Then I'm going to put my line, put my X, put my line. Whatever unit I started with, that unit goes on the bottom. Keep it simple. Whatever you see here, write it down there. Honestly, no thought process required. Monkey see this, monkey write this. That's what we do. Okay? Keep it simple. Too many students overcomplicate this, and that's why they get stressed out and they can't do them, because they're making it harder than it is. So we see moles of NH3 there. My conversion factor is right here. It's my mole ratio. So I'm going to convert to moles of my second chemical, which is whatever chemical the problem is asking about. And now I need to look at my mole ratio. Remember, our mole ratio was the coefficients in the balance equation. For nitrogen, it is a 1. For NH3, it is a 2. My moles of NH3 cancel. I'm left with moles of N2. That is not what the problem asked for, so I am not done. I put another X, I put another line. Whatever unit I see on top here, I put that same unit down here. And now I'm here. I'm at moles of B. Now I have to convert to mass of B by multiplying by the molar mass, which I already knew because I have moles on the bottom of my equation. Mass has to go on top. Now remember, molar mass has nothing to do with the balance equation. Molar mass is the mass in grams of 1 mole of your substance. I cannot tell you how many times students do that incorrectly. But that's not going to be you, right? You got that. 1 mole for your molar mass ratio. Alright, so now we look up on our periodic table. We see that nitrogen has a mass of 14.007, but our formula has 2 of them, so we have to multiply by 2. So we get 28.014. For molar mass, I would definitely try to keep at least 2 decimal places, just so you're not rounding too much. Molar mass is one of those quote-unquote exact measurements, so to speak, where we don't have significant figures in that number. We never use molar mass to determine significant figures. Okay, so as a general rule of thumb, when you're using molar mass, 2 decimal places is good. If you want to keep a little more like I did here, not a problem. Alright, so our moles of nitrogen cancel. We're left with grams of nitrogen. That is my final destination. Woohoo! Put on the coffee. We are there. We are at our final destination. So let's put an equal sign. Now all we have to do is multiply everything on the top. So I'm going to plug in my calculator. 2.56 times 1 times 28.014. Going to hit equal, and then I'm going to do divided by 2, divided by 1, and your calculator will spit out this number. But we are smarter than that machine. We understand significant figures. Our measurement in our problem had 3 significant figures. Therefore, we need to have 3 significant figures. We have a decimal, so we go to our first number. That is a non-zero, our first non-zero. We underline that and we go 3 digits. Okay, so we know what our answer is going to be. We go to the next digit just to see if we have to round up, and we do. Therefore, it's 35.9. And are we done? We have to remember to report our unit. Our unit is whatever we were left with that we did not cancel. Grams of nitrogen. Here's another type of problem we can come across. Please pause this recording, get as far as you can using everything that we've been doing in the last couple of problems, and when you are ready to move on, go ahead and hit play. Alright, so this one is converting moles of A to moles of B. How many moles of aluminum hydroxide? Oh, here we go. How many moles of aluminum hydroxide are needed to react completely with 12.3 moles of nitric acid? Well, reacting with it, so this one has to be my nitric acid. And so I have 12.3 moles of this chemical. Since we're given a value for this one, I know this is my A. I'm asked for moles of aluminum hydroxide, so I know this is my B. And I'm starting with moles of A, so I'm starting here, and then I'm finishing at moles of B. I'm making one jump and then I'm done. This is actually a one-step problem. It looks crazy though, doesn't it? Because it's a long, big equation and lots of words, so it looks complicated. But if you take it out of the word problem and just write down the information that's important, you'll notice it's not that bad. Okay, so we're starting the math problem. We're going to start with the number that it gave us. Start with what you know. So it's 12.3 moles of nitric acid. Then we're going to put our X, we're going to put our line. Whatever unit we start with, that is the unit we put on the bottom. And now when we look at our flow chart, we see that converting moles of A to moles of B, I have to write this ratio. Moles of A are on the bottom, which is something we already knew. We're starting with A, which is HNO3. And then we're going to moles of B, so I'm going to go ahead and write mole. My chemical for B is aluminum hydroxide, so I'm going to go ahead and write that down here. Where do I get these numbers from? You got it! If you said the balanced equation, you are correct. Aluminum hydroxide does not have a number in front of it, therefore that means it's a 1. Nitric acid has a 3. My unit for nitric acid cancels. I'm left with moles of aluminum hydroxide, which is exactly what the problem asked for. Therefore, I'm done. I put an equal sign, and let's plug this in on the calculator. 12.3 times 1 divided by everything on the bottom. So 12.3 times 1 divided by 3, and that gives us 4.1. Again, we have significant figures to look at. So my answer is my measurement is 12.3. That's 3 significant figures. My answer must have 3 significant figures. Well, right now I have only 2, therefore I can actually just put a 0 there. And now I have 3, and then my unit. So anytime you need to have more significant figures than your calculator gives you, you can add a 0 at the end. Most of the time, if you get an answer of 4.10, your calculator will not put the 0 there. And then we have our unit and our chemical, and that, my friends, is a correct answer. All together now, we're going to convert grams of A to grams of B. Go ahead, pause this recording, and get as far as you can following the same steps that we've been doing. Let's go ahead and fill in our information. How many grams of chlorine gas? So we have question mark grams. Our need can be produced when 62.3 grams of aluminum chloride decompose. Alright, so I see that my A chemical, my starting point is grams of A. And then I'm finishing at my B, and in fact, grams. Holy Toledo. I'm starting on the far left side, and I'm ending on the far right side. So my plan of action, I'm going to map out my route. The first thing I'm going to do is I'm going to start by writing down what I'm given, which was mass of A. And then I'm going to convert to moles of A. That's step number 1. Once I have moles of A, I'm going to convert to moles of B. That's my second step. And then my third step is once I have moles of B, I'm going to convert to grams of B. So this, anytime you go from grams of A to grams of B, is always going to be a 3-step process. Alright, let's get started then. We're going to get in the driver's seat, and we're going to start with what we're given. 62.3 grams. Our chemical is aluminum chloride. Then we're going to put our X, we're going to put our line. Whatever unit you start with, that's the unit that goes on the bottom. Now we have molar mass. When we look at our flow chart to help us, we see that we divide by molar mass. Well, we have the mass on the bottom, so we already knew that. And remember the definition of molar mass. The mass in grams of 1 mole of your substance. Notice how it is always, always, always of the same chemical. You can only have grams and moles in the same step of the same chemical. That's another very common mistake. Alright, so now what we have to do is get out our periodic table. We have aluminum and we have 3 chlorides. So we can't forget that we need to multiply the mass of chlorine by 3. We only have 1 aluminum, so that's not too big of a deal. Okay, and then we add them up. And when we do that, we get 133.33. My unit, grams of aluminum chloride, cancel. I'm left with moles of aluminum chloride. That is nowhere near what the question asked for, so I'm not done. I put another X, I put another line. Whatever unit I had up top here, I put that same unit down here. And now I'm in step 2. Step 2 says mole ratio, moles of A, and then up top we put moles of B. Well, what was B? B was chlorine gas. Remember, these numbers in front of the moles, that's our coefficients. So our coefficients is 2 aluminum chlorides to 3 chlorine. Be sure that you're putting the right number in front of the right chemical. And for all you students who like to take shortcuts and not include all your units, I will guarantee most of you, whatever that number is, will get those upside down. If you have 2 up top and 3 on the bottom, you're going to get a wrong answer. So please take that extra time and be thorough with your work. Alright, so moles of aluminum chloride cancel. We're left with moles of chlorine gas. That is not what the question asked for, therefore we are not done. We're going to put another X, put another line. Whatever unit we have up top here, that is the unit that we put down there. Okay, notice it's the same thing. Keep it simple. Alright, moles of chlorine. And now we see when we have moles of B, we now multiply by the molar mass to get mass. Well, we already knew that because we already knew moles were on the bottom, so grams have to go on top. We already knew that. Remember, molar mass is always of 1 mole. Okay, so we look at our periodic table. We see the molar mass of chlorine gas is 35.45. We multiply by 2 because our formula has 2 chlorines. Our units for moles of chlorine gas cancel. We're left of grams of chlorine. That is what the problem asked for. So, wipe the sweat from your forehead. We're done. We put an equal sign. And now we have to carefully plug this in our calculator. We're going to do 62.3 times 1 times 3 times 70.9 divided by 133.33 divided by 2 divided by 1, and your calculator gives you an answer of 49.69328. Once again, we are more intelligent than our calculators. Therefore, we know to go to our problem. Our measurement was 62.3, which is 3 significant figures. In our answer, we have a decimal, so we go to our first non-zero. And if we count over 3 digits, we'll see that our answer is going to be 49.6. We go to the next one just to see if we need to round up, and we do. Therefore, our answer is going to be 49.7. What? You're saying we're not done? I hope you were going to catch that. Right, we need to have our units. Don't forget, number without units, meaningless. 49.7 grams of chlorine. So when we look at everything, these are all the fun ways that we can do stoichiometry. The first two is just molar mass. Let me write that down, just molar mass, because you're sticking with the same chemical, A to A, A to A. So that's the same chemical. That was the first two problems that we did in this recording. The last four were the new stuff when you're going from A to B. So these are all the examples. We did one example of all of these in order. So if you need, you can go back and review. When you get to different problems in the future, these are things that you need to identify, figure out. Are they giving you moles of A, grams of A? And then are they asking you for grams of A, grams of B, moles of B? And then map out your route. You try. I would like for you to try this problem at home. Go ahead and pause this recording to give yourself ample time to work on this problem. And then when you're done, go ahead and hit play and see if you are correct. If you need to rewind so that way you can see a problem like this and be able to work through it, that's absolutely fine. Alright, let's go ahead and start working through it. How many grams of nitrogen gas, so it's asking for grams of nitrogen gas, are needed to form 4.36 moles of ammonia? 4.36 moles of ammonia. So I'm starting with moles of ammonia. That's my A. I'm finishing at grams of B. So therefore I have to make this step and then I have to make this jump. Alright, now I'm going to start with what I'm given, 4.36 moles of NH3. I'm going to put my line, I'm going to put my X, whatever unit I see there, that's the unit that I'm going to put down here. When I'm given moles of A, I use my mole ratio to convert to moles of B. My moles of B was moles of N2. I look at my balanced equation to see my coefficients, and that's what I plug in here. My units of moles of NH3 cancel. I'm left with moles of N2, not what the question asked for, therefore I'm not done. Put another X, put another line. The unit that I'm left with here up top, I just copy that same unit down here on the bottom. Once I have moles of B, I can multiply by my molar mass of B. Remember that molar mass is mass in grams of 1 mole of your lovely chemical. The molar mass of nitrogen gas is 28.014. My moles of N2 cancel. I'm left with grams of nitrogen, which is exactly what the question asked for. Therefore, I am done. Put an equal sign. And what we do is we multiply everything on the top. We divide by everything on the bottom. And my calculator gives me a fabulous answer of 61.07052. However, our measurement has 3 significant figures. Therefore, my answer is 3 significant figures. My next number does tell me that I must round up. Therefore, my correct answer is an answer that's to the sig figs, unit, and chemical. 61.1 grams of nitrogen. You try it. Number 2. Go ahead and pause this recording. Get as far as you can, and you can rewind if you need to go to the slide that has a problem similar to this. Figure out what you're given and where you're going, and you can find that slide. Let's go ahead and solve this problem. It says how many grams of nitric acid, that's right here, are needed to produce 124.6 grams of aluminum nitrate. That is right here. So I'm given a specific amount of aluminum nitrate, that's my A, and I'm asked for grams of nitric acid, that's my B. And notice I'm given grams of A, and I'm asked for grams of B. This is the long one. We have to convert mass of A to moles of A. That's step number 1. Once we have moles of A, we're going to convert to moles of B. That's step number 2. Once we have moles of B, we're going to convert to mass of B, and that's step number 3. So we have, to start with, 124.6 grams of aluminum nitrate. We're going to put an X, we're going to put a line. Whatever unit you see here, that is the same unit that we put down here. And then notice here we're going to be doing the molar mass. We divide by molar mass, which means grams goes on bottom. Molar mass is the mass in grams of 1 mole of your substance. So please be sure that you have that. It's 1 mole of your substance. And now we have to calculate the molar mass of this lovely chemical. So be careful with this because you have NO3, but you have 3 of those. So add up the mass of 3 oxygens and 1 nitrogen, add all that up, and then multiply that by 3 and add to it the mass of 1 aluminum. Again, this is material from 204 and 309. If you need to go back to learn how to calculate the molar mass, please do so. So you should get an answer of 212.99. I'm just double checking my number real quick just to make sure I have it correct because it's super easy to make a mistake, and if you don't double check, your final answer will be wrong and it'll drive you nuts. Alright, so grams of aluminum, just the unit cancels. I'm left with mole of aluminum nitrate. That's not what I needed, therefore I'm not done. I put an X, I put a line. Whatever unit is here is the same unit that goes down here. Moles of aluminum nitrate. And now I'm going to use the mole ratio. My moles of A are on the bottom. My moles of my B, which is going to be nitric acid, because that is what the problem asked for. Remember, mole to mole ratio is your coefficients. Nitric acid has a 3 out front. Aluminum nitrate does not have a number out front, therefore it's a 1. My unit of mole of aluminum nitrate cancels. I'm left with moles of nitric acid. Still not what I was asked for, therefore I'm not done. Put an X, put another line. Whatever unit you see here, you're going to put the same unit here. Mole of nitric acid. Now we're at moles of B. We're going to convert to grams of B by multiplying by its molar mass. Molar mass is the mass in grams of 1 mole of our lovely substance. We must add up the mass of 3 oxygens, 1 nitrogen, 1 hydrogen. We get roughly 63.01. And the moles of nitric acid up top there and on bottom here will cancel. We're left with grams of nitric acid, which is what the problem asked for. Therefore, I'm done. Put an equal sign. Now we're going to multiply everything on the top. 124.6 times 1 times 3 times 63.01. Then we're going to divide by 212.99 divided by 1 divided by 1. My calculator gives me an answer of 110.5833. Again, we're smarter than our calculators, therefore we know to go back to the problem. Our measurement that was given to us has 4 significant figures, therefore we have to have 4 significant figures in our answer. We look at the next number to see if we need to round up, and we certainly do. Therefore, it's 110.6, and you are correct if you included the unit and the chemical. 110.6 grams of nitric acid. If you got these two problems correct, or if you got pretty much there and only had a little bit of trouble, you are doing well. If you're still completely lost, I have a feeling it's probably because molar mass was never really learned originally, so please go back and do that. And that you really need to do more practice. Again, learning stoichiometry is kind of like learning the piano. You can't just watch somebody else do it and expect to understand it. It's not the way it works. You must do these problems, even if it's that every problem you do, you understand one more thing. It does take time. Stoichiometry is not something that you can learn in 1 hour. It is something that takes a lot of practice. Please use the extra practice in the lesson. There's a section in the activity tab where it has dimensional analysis practice. You click on that and it has the answers in there as well. And then if you need additional practice, use the practice sheet as well. It has been great working with you in stoichiometry. Please make sure that you are able to do all of these problems before moving on to 4.07.